Um, so for the agenda today, um, we'll look at some introductions and use cases for PySpark on Databricks. Then we'll go in to see what the who, what, and where of Spark and Databricks. Next, we'll look at Lambda architecture and see how we can leverage structured streaming using PySpark. And then finally, we'll look at some solution architectures that we can use both in AWS and in Azure. So I work for Kaizen Technologies. Here's my LinkedIn, and you can reach out to me on Twitter. And I've got a blog, SQL Stack, where I post some things about all things data, Python, and Databricks. Kaizen is a national service integrator. We're a Microsoft Gold partner. We're also a Tier 1 cloud service provider as well. We are hiring for any data or Python or C#. So what is Databricks? Databricks' vision is to accelerate innovation by unifying data science, data engineering, and business analysts as well as business users. The product is a unified analytics platform that's powered by Apache Spark. It was founded by the creators of Apache Spark at UC Berkeley back in 2008, 2009. And Databricks is the company that contributes mostly to the open source for Apache Spark. A few of the customers that are being used, Amgen, they use Databricks for pharmaceutical. So they're working on tackling diseases such as anemia, leukemia, as well as colon cancer. And they're running research efforts in order to come up with new pharmaceutical drugs to combat those diseases. Shell is another one who is using Databricks for their inventory management. For their oil rigs, they have these million-dollar parts that oftentimes need to be helicoptered in. And so they want to streamline that process and make it as cost-efficient as possible. We also have Viacom, who streams in they're a cable TV. They also have Paramount Pictures, MTV, Nickelodeon, and they use Databricks for managing the quality of the stream that goes out to its customers. HP, all of the printers that are out there are connected to the internet and constantly sends back the ink levels for your printer. And so they're constantly monitoring that and figuring out when to market and send you a notice in the mail to up your ink. There's also quite a bit of other customers in many different industries, from financial services to healthcare, entertainment, consumer services. My big focus is in energy and industrial IoT, working with a few customers there. So next, we'll go into what is Apache Spark and Databricks. So Apache Spark is open source programming language. It's also a data processing engine. There's some studies that were done quite a bit ago on how fast it's improved over Hadoop, up to 100 times faster for data processing. And the reason for this is because it is bringing all of the data up into memory and producing it in parallel across clusters. It's written in Scala, but there's also interpreters for Python, SQL, R, and Java. It's storage agnostic, so that means you can store it in Parquet files or Avro files, Hadoop, SQL Server, any kind of database. The real ecosystem, as we talked about, the core API of all those languages. On top of that, we also have SQL Spark, or Spark SQL, as well as data frames. This allows us a programmatic access to data sets using a common language that probably most of us are familiar with is SQL. The other real nice thing is streaming. So this is the Lambda architecture that I was talking about before. With streaming, you can bring in data and process it as it comes in, as you receive it. And we'll go into depth with that a little bit more. There's also a machine learning library that's built in that can do most of the common classifications or regressions. And then finally, we have GraphX. And what it allows us to do is process data in a graph format. So we can have like the main example is like Facebook or Twitter. You know, you have friends who like certain things, and those events and likes are how we can get a count of those events that take place. So Databricks they're a company that built, the founders built Apache Spark, and they are currently building out a web front end. This web front end allows you to interact using notebooks and manage your cluster all within a single web frame or a web browser. There's no need to install anything. There's no need for you know, purchasing hardware or anything like that. It also, as it shows here, you know, you've got the three main you know, data engineers, your data scientists, and business all collaborating together in this single unified platform. So every one of those three can access it via, you know, a URL in a web browser and be able to run, you know, big processing jobs that on data sets, as well as be able to have visualizations, build your predictive models, and be able to see those, you know, the predictions from there. AI is definitely a buzzword nowadays, but as we heard, it's been around for quite some time. It is starting to become a game changer. The main thing is we're getting lots of new data. So, you know, customer data, orders, sales, plus streaming information, IoTs, connected cars. And this gives us a lot of opportunity to like detect fraud. So I'm sure we've all got, you know, a credit card and have got the message that our card's being compromised and we need a new one. That's AI doing that for us. There's also genome sequencing. So we're able to, like with Amgen, they're able to come up with new drugs to help combat diseases. There's also recommendation engines like Netflix, as well as predictive maintenance. And the whole machine learning process requires, everybody to be a part of it at all phases and collaborate together in order to make the process better. But data is the hard part. This slide's from a report that Google put out for the NIPS conference back in 2015. We have all these different, configurations and data collection, the underlying infrastructure, buying the servers and getting them stood up and configured. But as you see right here, the ML code, the little green part, is what everybody's wanting to do. But we have this huge ecosystem around it that's required to even run that code. And big data and AI, the complexity of that to do on-premise is slowing innovation. So we have to set up and buy, optimize, configure this whole infrastructure in order to even store the data. Then we've got data pipelines, ETLs and streaming data that comes in that is, usually poor performant, nightly batch jobs or, something running every hour. That's stale data that again gets sent to analysts and data scientists who are unable to, perform their modeling in near real time. So this lack of collaboration reduces the quality of this whole process. With Databricks' unified analytics platform, with Spark being at the center, you can source your data from multiple different vendors, Hadoop, data warehouses, any type of cloud storage. And all of those can be found and leveraged inside of like AWS or Azure. And then the Databricks runtime is a more optimized Apache Spark engine that leverages and makes it much faster than just the plain vanilla Spark. We also have Databricks Delta that provides high performance for querying data and processing data. And then on top of all of this, we have notebooks that allow for creating code, working with others, collaborating, and eventually serving up models. All of this is secured using a single email account, and also extensible, so we can add this to the output to Tableau or Looker or Power BI. So, any questions so far? Oh, yeah. What do we have except notebooks? Can we use UI? So there are other ways to access this. There's command line interfaces that allow you to control some of the jobs as well as manage users. But for the most part, all your development work and visualizations are done inside of the UI for right now. That's a good question. All right. So next we'll talk about Lambda architecture. And it is a data processing architecture that's generic in nature, scalable, and fault tolerant, meaning that if one of the servers go down, the whole cluster continues to run. It's got low latency reads, updates, as well as ad hoc queries. And the gentleman who developed this is Nathan Mars, and I highly recommend his big data book here for learning more about that. Some of the design principles behind Lambda architecture. Typically, when processing data with Python locally, you might be connecting to an ODBC driver and moving something from Oracle to SQL Server. This is typically been a nightly job or an hourly job that would then populate your master data set or a data warehouse or the master copy of things, which is then served up to reports like Power BI, SSRS, that can then be, or ad hoc queries can be run against that as well. With Lambda architecture, it adds a speed layer, which is as data comes in or received, we're able to send it both to the batch layer as well as our streaming layer in order to get real-time views of that data and combine queries across both. So some real-world examples of this, like we talked about a little bit before, is fault or fraud detection in credit cards or any type of banking transactions. With manufacturing, there's plenty of logging that's done from IoT devices and robotics. In networking, we want to keep networks as secure as possible. So monitoring those and keeping track of what's coming in and what's going out is definitely a security risk. With marketing, definitely sending out ink levels from HP or other shopping venues that need to send out ads. The way structured streaming is handled inside of Databricks is there's a table that's unbounded and allows for new records to be sent in and just appended to that table. So there's no upserts or anything like that. It's just a true append, similar to like a log file or so in order to wrap up for today, we'll look at an example of a fraud detection system where we would have data coming in with geolocated data or ATM transactions, and that data comes in through an ETL process. We might visualize it before we perform any other necessary data cleanups or things like that, using matplotlib or any of the built-in visualizations. Then we can definitely use the built-in Databricks MLlib, but we can also leverage like scikit-learn, as well as maybe even some of the deep learning of TensorFlow. And the outcome is to reduce fraud and get ATM more secure and quicker turnarounds in mitigating that risk. Kind of a overview of an architecture of a website. People could be ordering things on your website, and as they're clicking around, you want to know where they're going, what they're clicking on, and try to make it as quickly and easily accessible for them to place orders. That data can come in streaming, and then you can also have your inventory be brought in as well and combined together in like a Azure Data Lake or another storage, and then be able to receive real-time KPIs and alerts for maybe somebody put in, a really large order, and you need to make an adjustment in your inventory and purchase more raw goods. Then we can have part of that go into machine learning and maybe predict when we need to re-up our inventory levels, as well as be able to show our bosses that this month is looking really good, and we definitely want to see the sales marker going up. So some of the vendors that integrate with Databricks, we've got like SAP, Salesforce, MicroStrategy, but there's also a lot of cloud vendors, Oracle, SAP, MySQL, Postgres, as well as integration with source control. So all the code that you write can be saved into GitHub for source control processing. And with that, that's all the talk I had today. When we get done, I'll send the slides out. There's quite a bit of information that I didn't cover. I've got some links in this slide deck. There's about another 10 or so pages of links on getting started with it, and it's all free. They have a community edition that you can sign up for, and you get like 10 gigs for free, and can work with PySpark and build out things. Got some blog posts in there, and there's a bunch of video resources as well. So,
you have questions for Lucas?
Yeah.
I have a question about the first link you had on the resources was like a Microsoft specific link for Azure.
Uh-huh.
Is that to offer a hosted Databricks service?
Yes, they sure do. They have a version, and AWS has a version.
What's AWS's version?
Just Databricks.
Okay.
Yeah. And with the Azure version, you can incorporate it into like SQL Data Warehouse or Azure Data Factory, Event Hubs, as well as like on the AWS side, Kinesis or Redshift. It supports all of those.
That was my next question about support for Kinesis.
Yes.
Any other questions for Lucas about Databricks and PySpark? Oh.
Yeah.
Yeah. Let me get you the microphone here.
Which one of those links would you recommend to just kind of dive in and get your hands dirty a little bit?
Definitely check out Databricks.com, and probably this one for the community edition.
Okay, thanks.
Yeah, you're welcome.